Oh, this is example 2. There's example 3. All right. So we have a retaining wall. So you've got some kind of wall that's holding up stuff and keeping dirt out and sort of thing. And because of what's pushing up against it, it's starting to lean at an angle of 70 degrees. So I'm going to draw that wall. Here's the ground. Now our wall has started to lean at 70 degrees. So sometimes what a retaining wall, there would be like dirt on this side that you don't want to fall over, and so they build a wall to stop that dirt. But dirt is heavy and ground moves, and so it might over time push this wall that was straight up and down over a little bit. That becomes dangerous, right? Especially for the little kids playing underneath the wall. You're like, oh, this is looking dangerous. So we need to put a support. And a rigid support is to be placed 5 meters from the base of the wall. So if we go 5 meters away and attach 2.5 meters up the wall on its base. So this length right here is 2.5 meters. We want to determine the length of the support, that would be this x right there, to the nearest tenth of a meter. And then measure the angle between the support and the wall, I'll mark that as theta, to the nearest degree. So basically they're asking us to solve this triangle. Because once we found x and theta, there would only be one angle left, and they would all add up to 180, so it wouldn't really be hard to find that last answer.
We just use basic subtraction.
So this question is basically asking us to solve the entire triangle. What is the hardest part in these questions would be exactly what we did first. Can you draw the picture? Can you read the question and draw the picture? Okay? If you can't draw the picture on a final exam, do the best that you can. Okay? So you're stuck with drawing the picture. Try the best that you can to draw the picture, because then if your math is similar, like if you create a problem that you would solve a similar type of question, then you'd be able to get some marks for that. So, solving this triangle, first of all, what's that? Whew. Sine law, cosine law, one of the superintendents. So, another day that I didn't get fired. Oh man, and that'll be on YouTube. Anyways, so, looking at the picture. Sine law, cosine law, SOHCAHTOA, cosine law. So we go, and which form are we going to use? Are we solving for an angle or solving for the side? Well, but what would we solve for first? Would you solve for theta first, or would you solve for x first? You'd solve for the x. So we go to our formula sheet, and on our formula sheet, you have that formula. Again, the thing that we have to remember is that angle and that side go together. So if we're solving for x, in our question it would be x squared, the angle you're using will be cos 70 in the end. And the other two, which one's a and which one's b, doesn't matter. So 2.5 squared plus 5 squared minus 2 times 2.5 times 5 cos of 70 degrees. We can type this into our calculator all at once. 2.5 squared plus 5 squared minus. And we get x squared is 22.7. So square rooting that. 4.76, does it ask to the nearest tenth? So it'll be 4.8 meters. So now we know that this x is 4.8. Now, if I gave you this triangle now with the 4.8, and you wanted to solve for theta, sine law or cosine law, or SOHCAHTOA. You could use sine law. Do we have an angle on an opposite side now? Yes. Could you use cosine law? Yes. Because you have all three sides. So you have enough information that you have some choice.
Is there any possibility that you can't use the same law, but you can't use the cosine law?
There is a possibility of that, but once you've done something first with cosine law, you'll have 4 pieces of information. And once you have 4 pieces of information you will always have an angle and an opposite side, so you'll always be able to use the sine law. I personally like to use the sine law more than the cosine law. There's less things to put into your calculator, and it just seems a little bit simpler. So whenever I get the opportunity to use the sine law, I like to do that. Yes?
Will there be any questions of this on the non-calculator section?
No. This will always be calculator. So, I want to find theta. Sine of theta over 2.5 would equal sine of 70 over 4.8. Multiply both sides by 2.5. Go to our calculator again. And 0.489, do sine inverse of that, and we get theta equals 29.3 degrees. To the nearest degree would be 29 degrees. So we've solved for the length and we solved for the side. I could have made this exact same question, well, with the 70 degrees here, it would have been really hard. But there is a possibility in these questions, and this is what's called the ambiguous case for cosine law. I don't have to teach it to you. They make sure that the questions never have the ambiguous case with the cosine law. But at this point, right, if we think back to 6.2, sine is positive, right, which technically, according to the CAST rule, could mean quadrant 1 or quadrant 2. And this 29.3 would be the reference angle. So in quadrant 1, it would be 29 degrees if we round to the nearest degree. If that reference angle is 29 degrees in quadrant 2, then this angle would be 151 degrees. The nice thing about our triangles, we know that 151 isn't the possibility, because if it's 151, then our triangle adds up to over 180, which is impossible. So we know that the answer has to be the 29. Okay? But I could make a question where the answer that you get here should be the bigger one and not the smaller one. Okay? One of the ways to figure that out is, in the end here, I've got 70 degrees here, 29 degrees there. That adds up to 99. So that means this last angle here would be 81 degrees. And if you ever in the future run into an ambiguous case where it should have been the bigger angle rather than the smaller angle for 29, one way to check is in your final answer, the biggest angle should always be opposite the biggest side. Because the wider the angle it is, the farther that side will be apart when you get to those endpoints. So when we look at our triangle, we see the 81, the biggest side is the 5. That matches up. Second biggest angle, the 70. Second biggest side, 4.8. Smallest angle is the 29. Smallest side is the 2.5. That'll always happen with triangles. question was asking measure between the support and the wall. It was asking for the 81. Good, we did have to solve the whole thing. Oh, we could have used the sine law with the 5 and got the 81 that way too. Yeah, my theta was in the wrong spot. Wait for it. There we go. Whoops. Oh, man. I gotta maybe bounce it off. One more try. Oh! Okay. Close enough. There, we'll put it there. There's the theta. That's what we were supposed to solve for. And the questions you can do for this one are 5 and 7. So what's the average? I already assigned 5 and 7. What's the average of 5 and 7? 6. Let's do 6.